In this short video, we're going to go over one component of the supplier's optimization problem. So let's first look at what the supplier's optimization problem is. Well, we usually assume that a firm is going to want to maximize its profits. So it's going to want to choose the quantity of output that maximizes its profits, where its profits are simply its revenues as a function of the quantity they produce, minus the costs as a function of the quantity they produce. And revenues are simply equal to the price that they're able to charge as a function of the quantity that they produce times the quantity that they produce. And again, we'll subtract off the costs. Okay, so the basic idea here is the firm's going to choose a quantity. That quantity is going to determine the price. So if it's a monopoly market, the relationship between quantity and price simply follows the inverse demand curve. We're going to look at a number of other more complicated markets where it's a little bit more complicated how price relates to the quantity of output of the firm. And that's going to be the topic of a number of lectures, 3 or 4 lectures later on in the class. In this class, we're going to focus on how to find the cost function. The cost is a function of the quantity of output. Because you need both of these to be able to use the optimization tools, the math optimization tools, to maximize profits. We need to know all these components. And if you think about it, it's not exactly obvious where the cost function comes from. It's not actually a trivial problem. So if you think about it, there are actually many ways to accomplish some goal or make a product. Let's think of a relatively simple task of digging a giant hole. You could either do it by hiring a lot of workers, but then only spending a little bit on this complementary input, shovels. Or you could only hire a single worker. Okay? And you could complement their work with a very expensive big digger, right? Because they want to know what is the lowest cost way of producing a given quantity. Not only that, but they want to know what the cost will be for any given quantity, assuming that they're producing said quantity at lowest cost. Okay, so let me give an example. We're gonna use something called the production function. So let me write that down here. The production function simply relates the quantity of output to the amounts of the two inputs used. So it's some function of capital K and labor L. And we're going to assume that those are the only two inputs in this market. And this function is going to reflect the fact that you can accomplish this quantity of output with different combinations of capital and labor. So first of all, what are capital and labor? Well, labor is somewhat obvious. It's basically man hours or certain amount of work from people. So L determines the amount of those man hours. K is the amount of capital, where capital is defined as inputs which are not labor, but are not used up in the production process. So for example, capital could be something like machinery that augments the production process, but is not a material that actually goes into the final product. So it's not actually used up in the production process. Shovels in that previous example were a form of capital, as was a big digger. Okay, so the first step to solving this problem is to figure out this production function. Now we're not going to figure out where this comes from or what the exact form of the production function is in this class. In a given context, you might be able to figure this out by varying the amounts of capital and labor, and then estimating the production function using the tools that you'll later learn in your econometrics class. For today, we're going to assume that it's known. It could, for example, be that the production function is equal to capital raised to the power of 0.5 times labor raised to the power of 0.5. Okay? And it's pretty clear that you can increase output by raising the amount of capital used, raising the amount of labor used, or some combination of both. And our goal is going to be find the cheapest way and to also find out the cost function that sort of tells you the cost of producing a certain level of output for any level of output, assuming whichever level of output you choose, you're producing that output at lowest cost. Okay, so there's actually going to be two separate problems we're going to look at. We're going to look at the short run case, which is simpler, and the long run case. The short run case is defined as a period of time where it's too short to vary one of the inputs. It's usually assumed that capital is the input that cannot be varied in the short run. So suppose you have some complicated production process that uses rather simple labor. It might be that you have to order very far in advance a very specialized piece of equipment that's used in the process. You might not be able to increase the amount of machinery you're using for several months, but presumably you can post an ad and have more labor in there like the next day or 2 days later. So in the short run, we typically assume that capital is fixed. It's whatever level you set it at before, and the only input that you can actually adjust is the amount of labor used. In the long run, we're going to assume that both capital and labor can be adjusted, and so you're going to have to think about what is the optimal combination of the two to produce the good at lowest cost. Okay, so let's talk about how you actually solve for the short run cost function. How you find how to produce a given quantity at lowest cost, which is actually trivial in this case, and then find this function which relates the cost to the quantity of output, which is what you want to plug into this firm profit maximization problem. So the cost function, there's the cost of the quantity of output, is going to be equal to the wage, which is the amount you have to pay per unit of labor, times the amount L of labor used, okay, plus the price per unit of capital, which we're going to call R, times the amount of capital used, which is represented by K. Okay, and actually I can make this very clear that we are solving the short run production problem by indicating that the amount of labor used is going to be a function of quantity, right? And the amount of capital used is not, because that's going to be fixed in the short run. Okay, so usually in the problem you'll assume that the wage rate is known. The amount of capital is fixed in the short run to a known amount, and the price of capital is also fixed. And so to get a cost function which tells you the cost as a function of the level of output, what you need to do is you need to find this function here. How much labor is needed to produce a given level of output? And once you plug that in, then you'll have a function that's in terms of the quantity of output rather than the amount of labor used, which is, again, what we want. Okay. So how are we going to do this? Well, you can often invert this production function and solve for L. Okay? In the short run, since capital is just a number, it's fixed, once you solve for L, you'll have a function that is just in terms of the quantity of output. So let's go through an example. Let's suppose in a particular problem that W is equal to 4, R is equal to 5, and the amount of capital in the short run is fixed at 9 units. So this cannot be adjusted, at least in the short run. And the question that I have is, what is the cost of producing 5 units? Okay, so, there's one other thing I have to do, just to say what the production function is. So the quantity of output is equal to this function of capital and labor, which in this problem we are assuming is equal to K raised to the power of 0.5 times L. Okay. So this is sort of the setup of the problem. And now we're going to try and solve it. So as I said, the first step to solving the short run problem of the firm is to invert this production function to solve for L. So let me just be clear. We have that the quantity of output is equal to K to the 0.5 times L. To invert this function and solve for L, all we have to do is to divide both sides by K, or capital, raised to the power of 0.5. So we get Q over K to the 0.5 is equal to L. Okay. So this is this function L of Q. Now we know how much labor is needed to produce a given level of output. It's simply Q divided by capital raised to the power of 0.5. And actually in this problem, we know that capital, at least in the short run, is fixed to 9. So this becomes that Q over the square root of 9, which is just 3, is equal to this LQ. Okay, so now we have enough to go back and plug it into this cost function here. So we have that the cost as a function of the quantity of output is equal to the wage rate, which in this problem is 4, times the amount of labor used to produce a given level of output, which we now know is equal to Q over 3. And then we're going to add to that the price of capital, which is 5, times the amount of capital used, which in the short run is fixed at 9 units. Okay, so this just becomes 4/3 times Q plus 45. Okay, so for the short run problem, where capital is fixed in the short run, we've now derived this cost function. This cost function is what we could plug in here when we're trying to solve the firm's profit maximization problem. So in the next short video, I'm going to go over the long run problem, where it's a little bit more complicated because the firm has to figure out the optimal amount of labor and capital to produce the given level of output at lowest cost. This was not something we had to worry about for the short run problem, but we do for the long run problem.